We're going to go over a kind of a different twist on this reaction mechanism example to answer a few questions, and I'm going to highlight a bunch of the key points from this section here of the text. The following mechanism has been proposed for the reaction of CHCl3 and Cl2. So we have three steps here. We have Cl2 in equilibrium with 2Cl, which is a fast step. We have Cl gas plus CHCl3 gas in equilibrium with HCl gas plus CCl3 gas. And the third step is Cl gas plus CCl3 gas in equilibrium with CCl4 gas. And again, this is a fast step. All right. Notice that we have equilibrium arrows here, meaning that there's a forward reaction and a reverse reaction happening kind of at the same time, and it's in something called dynamic equilibrium, which we're going to cover in the next chapter. Okay? But looking at this now, we can kind of decipher some of a few things here. The first thing I want to ask is, what is the overall reaction? And to get the overall reaction, we simply need to add up all three steps of this particular reaction. So if we do that, we're going to get Cl2 gas plus 2Cl gas plus CHCl3 gas plus CCl3 gas in equilibrium with 2Cl gas plus HCl gas plus CCl3 gas plus CCl4 gas. If we look at this, we see that Cl shows up on both sides of our particular reaction, and CCl3 also shows up on both sides of the reaction. That gives an overall reaction of Cl2 gas plus CHCl3 gas in equilibrium with HCl gas plus CCl4 gas. Part B of this problem is going to ask us which species are intermediates. And remember, our intermediates show up in the elementary steps, but not in the overall reaction. So they are the species that we crossed out in the reaction here I listed for part A. So Cl gas and CCl3 gas are going to be our intermediates. C is going to ask us, what is the rate determining step? And remember that our rate determining step is going to be our slowest step. So that's going to be step number 2. And lastly, I'm going to ask, what is the predicted rate law? And remember, we can look at the rate law, and we need to determine the rate law from the rate determining step. So we can say that rate is going to be equal to K times our concentration of Cl times our concentration of CHCl3. So we can kind of write this as our rate law, but there's something that's kind of fishy about this, because if we look at our overall reaction, we have CHCl3 and CHCl3 down here, but we have Cl2 over here and just Cl down here. So this should raise a red flag and say, we can't have a species that's an intermediate be in the predicted rate law. So this particular rate law needs to be expanded upon, and we need to make sure that it contains the concentration of Cl2 and the concentration of CHCl3. So this Cl right here is not allowed. And in the next video here, I'm going to introduce something called the steady state approximation, which is going to allow us to write out the predicted rate law for this particular reaction.